Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today I am going to explain step-up chopper. In that step-up chopper, output current and output voltage derivation. Next with RL circuit. So now here in this, so the first, before going to explain this step up chopper, what do you mean by chopper and chopper applications? Choppers are widely used in applications like battery charging and voltage regulation in the power systems, and in the motor drives, DC motor drives, and in the renewable energy systems. Additionally, these choppers are used in the filters, so such as low pass filters to reduce the voltage ripple and harmonics in the output waveforms, and ensuring a stable and clean power supply. And this feature is particularly important in sensitive electronic devices and applications where constant and high quality power source is essential for optimal performance. So these are the applications. Chopper is actually it is a DC to DC converter. DC to DC converter. Now here, next here, what is chopper? So it is an electronic device designed to control converter electric power in the direct current systems. So that is DC system to the DC system. So it operates by interrupting or chopping the input DC voltage into the pulses using semiconductor switches. What are the semiconductor switches? Yes, here what are the semiconductor? CR, MOSFET, IGBT. So all these are semiconductor devices. That means thyristors, transistors. So now here, these choppers are classified into three types: step up choppers, step down choppers, and step up or step down chopper. Step up chopper is known as a boost converter, and step down is a buck converter, and buck boost converter is a step up, step down chopper. And now here, this is a step up chopper. So here the components used in the step up chopper is a inductor, and next one switch, semiconductor switch, and one diode we will use. This is a load, and one supply I'm using. So now here, components used in the circuits. So now here step up chopper is constructed with key components such as a power supply. So this is a power supply and power switch. So this is a power switch and boost converter inductor, boost inductor, and stores the to store. Why we use this to stores the energy and transfer the energy. And one output capacitor is used here, or one output capacitor to filter the voltages, and one freewheeling diode is used, one freewheeling diode to provide the path for the inductor current during the switch off periods. And this control circuit, so which includes feedback loop and regulates the output voltage by adjusting the power switches. There is a duty cycle. So by adjusting this duty cycle, we can change the output voltage. And next, additionally, we can use this one. This is a optional snubber circuit, so it may be added. So for the damping, so to reduce the voltage spikes, we will use the snubber circuit. And now here, so here what are the components? First component is the power supply. So the input to the step up chopper, this is a chopper. The input to the step up chopper is a DC power source, and this may be a battery, and rectifier AC power. So rectified AC power. AC rectifier means which converts from AC to DC. That DC output power is given to the step up chopper or any other source of DC current source. So it is clear. And what about the switch? So switch is the main part. So it is a important part in the step up chopper. And now here it is a semiconductor devices we will use that switch, either it may be a IGBT or thyristor or MOSFET or transistor we will use. And the switch is responsible for turning the input voltage and turning off the controlled manner. So now here we can turn on and turn off. And next, what about the inductor? Inductor is also main component in the step up chopper. So what is the main purpose, main property of inductor, which stores the energy in the form of electromagnetic field? It is a passive element. So now here what how it will be used in the step up chopper. So first here it stores the energy. When we supply is given to this one, when it is closed circuit, energy stored in the circuit. When it is open, it delivers the power to the load and it comes back to for this particular circuit only. And when switch is on, so it stores the energy, and when switch is off, it releases the power. In this particular case, it is depending upon the circuit. And this inductor helps smooth out the output voltage and current. And next, what about the current? So here there may be in the output voltage, there may be voltage ripple. So to reduce that output voltage ripple, so we will use this capacitor. Is here output voltage before this load. So capacitor is often connected at the output of the chopper. Uh, to filter out the output voltage and to reduce the ripples. So it helps the maintain a ripple, a more stable and continuous output voltage. So now here, what about this diode? It is a freewheeling diode. It is connected in parallel with the load. And when power switch is when switch is open, when switch is off, so this freewheeling diodes provides the path for the inductor current. So here this is the load, and when switch is open, and this current will relay the inductor stores when switch is closed, inductor stores the energy. When switch is open, this inductor releases the energy. So here this freewheeling diodes provides the path for, so here this provides the path for, so here a path for the inductor current to circulate in this and prevents the voltage spikes. And here control circuit is responsible for regulating the output voltage of the step up chopper. And next, it includes the feedback loop that monitors the output voltage and adjusts the so how it will so it will adjust the duty cycle. So and we will get the output voltage, we will see. And another one is just number circuit for the semiconductor devices. So here, so number circuit main purpose is it will dampens the voltage spikes and reduces stress on the power switch. So what do you mean by power switch? Is here IGBT or MOSFET or thyristor or ICR or transistor. And this is the step up chopper. Step up chopper. So here we are using power source is represented with Vs, and inductor is L, and switch is S. And next here this is diode D, freewheeling diode. This is a C capacitor, and this out load is the RL load only I am taking. And voltage across the inductor is a VL, and current flowing through the inductor is a SIL, and output voltage is a V naught, and output current is a I naught. And this current is the current flowing through the capacitor is a IC, and current flowing through the switch is a IS. So now here when switch is on. Switch is on. So what will happen when switch is on means this switch is closed circuit. So now here what will happen? So if you apply KVL in this loop, so minus Vs plus VL is equals to 0. So this is a KVL equation. So now here VL equals to Vs. VL on equals to VL on equals to Vs only, supply voltage. And now here inductor voltage when switch is on and capacitor current when switch is on. So now here, so if you apply KCL at this node, so here, so sum of entering currents equals sum of leaving currents. But is there any current in this diode? So no, there is no supply. It is short circuit. This voltage is zero completely, and this current is zero. So this current is directly go to this branch. This current is zero, and this current equal IC plus I naught equals to 0 if you apply KCL at this node. So IC equals to minus I naught. So IC when switch is on equals to minus I naught. So keep it in mind. Inductor voltage and capacitor current when switch is on is Vs and minus I naught respectively. Same way when switch is off. When switch is off means this is open circuit. This is open circuit means here what will happen? This Vs equals, if you apply KVL in this loop, so this is open circuit. So when switch is off, what will happen? So minus Vs plus VL plus V naught equals to 0. So now here Vs equals to plus and minus plus and minus. So now here Vs equals to, so VL on equals to VL off equals to Vs minus V naught. So in case of when switch is on, so VL on, so that equals to, that is Vs. Same way if you apply KCL at this node, there is a current, current is entering. So now here IL equals to I naught plus IC. So now here I need the inductor capacitor current equals to IC equals to IL minus I naught, that is IC off. So here IC off equals to minus I naught on equals to. So now here this is the voltage across the inductor when switch is on and switch is off, and current flowing through the capacitor when switch is on and capacitor is when switch is off. And now here we know very well volt second balance. So VL on T on plus VL off plus T off is equals to 0. We know very well about this equation. So now VL on is this is V naught, I think. Okay. So this is Vs, I think. Vs. VL equals to Vs only. So now here, T on equals to, here T on equals to, here T on is, this is the time period. So T off. T on and this is T off. So duty cycle D into T, and this is 1 minus T into T, and this is total time period T. So T off, T on is a delta into T, D into T, and T off is a delta 1 minus delta into T. D means duty cycle, D or delta. So now here VL on is a Vs and T on is a DS, D into S, and VL off is a Vs minus V naught and 1 minus D into T total time period. So now here T is a common term. So here we can derive this one. V naught output voltage equals to V naught output voltage equals to V naught output voltage equals to 1 by V naught equals to Vs into 1 minus D. So this is the final expression for output voltage when this output voltage is R. Okay, now Vs into Is equals to V naught into I naught. So Is equals to I naught by 1 minus D. So now here next, ripple in the inductor means here when during turn on, so VL equals to Vs. So here VL and means DIL by dt equals to Vs. So now here dt means here, so L into del IL, so that equals to Vs into, so now here dt indicates the this delta T into Ts, and now here delta into Vs by, so now here L del I equals to 1 by L and into LF. So this is a ripple in the inductor. I hope it is clear to you. And now here, what about the capacitor, ripple in the capacitor output voltage, output current, output voltage, and now here IC equals to minus I naught, and IC means capacitor current equals to dVc by dt. So C into del Vc by, so this is delta T, and this one is also equals to D into I naught by F into C. So this is the formula for ripple in the capacitor and ripple in the capacitor voltage and capacitor current. So now here, what are the advantages of step up chopper? Step up chopper means here, main advantage here, ability to increase the output voltage. We are increasing the voltage, output voltage. Output voltage is greater than the input voltage. We are boosting the output voltage, and this is particularly useful in applications where higher voltage is required than the input voltage. And next, it can be designed to operate with higher efficiency, especially when well designed power electronics components are used. Efficiency is crucial in the many power conversion applications to minimize the energy losses. And now here step up choppers provides the flexibility in converting different DC voltage levels, so they can be employed in the various systems, so where the adjustable output voltage is necessary. And now here step up choppers find applications where the renewable energy systems, that is solar and wind power systems, we will use step up chopper. The solar actually some less amount 12 volts 30 volts will be generated to increase the DC voltage. Solar output voltage is DC. To increase that voltage levels, we will use this step up chopper. And now here the step up choppers can is also, so output voltage needs the increased for efficient power transmission and storage purpose also, can be utilized to improve the power factor also. To improve the power factor, power factor means here cos phi. So to improve the power factor, so we will use step up chopper, and step up choppers can help in the regulating the output voltage and providing the stability in the applications that requires a constant or regulated voltage levels. So these are the advantages, but what about the drawbacks? So what are the disadvantages? So disadvantages here, so they they are operating high switching frequency to achieve the boost. So now here, so here when we operate at a high switching frequency to achieve the high boosting voltage, now here, so there may be higher switching losses. And higher switching losses means losses increases means here overall efficiency will decreases. This is one of the main drawback. And now here second drawback is here the rapid switching of the chopper can generate, it will generate the electromagnetic interference, and that interference, electromagnetic interference affects nearby electronic devices and potentially causing the signal distortions or malfunctions in the sensitive equipment. So this is second drawback. And next here, the control system for step up chopper can more complex as compared to other voltage conversion systems. So the complexity is increases in the step up chopper. So now here a precise control of duty cycle and switching frequency is required to achieve the desired voltage boost. And this may have more ripple as compared to the other voltage conversion techniques. So the ripple can be problematic in the applications where stable output voltage is crucial. And now here, what are the applications? In the, as we have discussed in the solar PV, it generates low voltage. So now here to we need the high voltage to increase the out. What is the main uh, in the solar PV, less amount will be generated. Photovoltaic panels generate low voltage. So here we need the high voltage to increase that to increase the voltage. So we are using the step up chopper. So they are used in the solar panel, solar systems. And now here it is when grid tied inverters are uh, now here batteries. So here, so battery power devices. So now here step up choppers can be employed in the employed to boost the battery voltage to level the level of required voltage. So here next third one, the electric vehicles, this is important. So step up choppers are used in the electric vehicles to increase the battery voltage to levels. Same application, but it is used in the batteries and it is used in the electric vehicles for efficient motor operation. And step up choppers are extensively used in the industrial applications. What are the applications here? For motor drives, servo systems, and they enable the precise control of motors, provides and torque by boosting the supply voltage to meet the motor operational requirements. And in the telecommunication industry, step up choppers are employed to power radio frequency amplifiers. So higher voltage levels for which requires the higher voltage levels for effective signal transmission. And now here, these are the advantages, disadvantages, operation. And now here, step up chopper has one problem. Step up chopper input voltage, this is Vs, and output voltage is V naught. So what is the pulse width of output voltage, non-conducting time of that is 100 microseconds. So now here, what is the pulse width? So how you will calculate? So this is a Vs and this is a V naught. So here from this duty cycle calculate. So duty cycle is equals to here. This is 240 by this is 680, and now here duty cycle equals to 0.64. So now here another formula is duty cycle equals to T on divided by T, that equals to T on divided by T on plus T off. So here non-conducting time is given. So this is given. So 100 is given. So from this calculate the conducting pulse width. So what is the pulse width? Means here conducting time of thyristor. So that is T on. So T on is 177.7. So that is in microsecond. This concept step up chopper definition, and step up chopper circuit configuration, components, and that operation, and output voltage derivation, output current derivation, volt second balance. And next here advantages, ripple in the capacitor for boost convert, step up chopper, and ripple in the inductor current and in out capacitor voltage. And next here, advantages of step up chopper, step down chopper. Next applications, next one problem. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you very much to you all.
Like, share, and subscribe. Hit the bell icon for more updates.